All right, in this lesson, 5.4, factor and solve polynomial equations. What our goal is to find the x-intercepts for our graph. We did this with quadratics. That's where we first did factoring together this year. And each time we solved a smaller equation. So factoring allows us, that's what the goal is, it allows us to solve a simpler equation. So that's our goal, okay? How do we do that? What does it actually mean to factor? This is what it allows us to do, but what does it mean to factor? So again, we're going to define factor. Factors are the smallest units that when multiplied make a product. So define factor. The factor is the smallest unit that when multiplied, I'm a terrible typer too, makes a product. Probably a little bit repetitive because product means that are things that are multiplied, but I also want to do this as a verb. So to factor means to find those smallest units. You did this first in like 5th grade. You made a factor tree. And if you started with something like 24, good first example. Let's say we started with 24. If you made a factor tree, you did like this, and then you said, what's something that I know that goes into 24? Maybe you said 6 times 4. So we can't stop there. Although 6 times 4 makes 24, they're not the smallest units that make 24. We have to go further. So we have to factor 6 into 2 times 3. And then we have to factor 4 into 2 times 2. And so the smallest units that make 24 are 2 times 2 times 2 times 3. Or you could have written 2 cubed times 3. So this is factoring a number. We're finding the smallest units that make up 24. We want to do this same thing with polynomials. So when we factor polynomials, we're going to end up with binomials, small units, maybe a monomial, that represent the smallest units for that polynomial, and then those are what we use to solve the equation. When we factor, it must be the equation must be set equal to 0. That's a requirement. 0 is the only special number that if you multiply anything by 0, you still get 0. There's not a number that you could multiply anything by and get 4. There's not a number that you could multiply anything by and get 10. There are no other special numbers. That's called the 0 product rule. So 0 product rule. Because it's special, any number multiplied, see product, any number multiplied by 0, multiplied by 0 is 0. That's the definition of 0 product rule. You should be able to define this as well. So when we factor, we're going to set it equal to 0. We are going to try to find those smaller units. And we know a little bit about factoring, but we're going to take it to the next level now that we have polynomials of higher degree. So we're going to have polynomials of degree 3 and 4 that we're going to factor and find all of those x-intercepts. So solve a simpler equation. Those solutions are x-intercepts. So this is pretty much review. We've talked about this before. Now I want to take a look at the diagram that I've started on the left-hand side. So what I have are the things that you need to know in order to factor these higher degree polynomials now. So every time you look at polynomials, we need to think about first the greatest common factor. This is always what we're going to factor first. So greatest common factor, GCF, greatest common factor. It's so much prettier when I type. Anyway, that always comes first. You want to take your polynomial down to something simple so it's easier to factor. So number one, greatest common factor. Then you're going to look at these three things next. Your polynomial is either going to be a binomial with 2 terms, it's going to be a trinomial with 3 terms, or it might be a 4-term polynomial that you're going to use factor by grouping. And so this is the first level. You're going to take out the greatest common factor first, and then it's either going to be a binomial, a trinomial, or a 4-term polynomial. So step 1, and then this is level 2. If you find that it's a binomial, those are all special rules. So you've either taken out the greatest common factor first, and then after that, if it's a binomial, it's going to be something special. So it's either going to be a difference of squares. We're going to learn difference of cubes in this section. So now I have a cube. And we're going to learn a sum of cubes. So special factoring forms if it's a binomial. So that's got 2 terms in it. So that's supposed to have an R in there, 2 terms. If it doesn't have 2 terms and it has 3 terms, it's a trinomial. So 3 terms. It either has something like a x squared plus bx, bx plus c, or maybe it's just x squared plus bx plus c. In either case, we look at the factors of a times c in order to factor this. And sometimes we use guess and check. Sometimes we listed the factors of a and c out and use that to guess and check. We also can use the factors of a and c to help us do factor by grouping. So the factors of a and c, and those factors must then you try and error to get the b term. So those factors of a and c, then add up or subtract plus or minus to make b. If it's not a binomial or a trinomial, then probably it's a 4-term polynomial, and we're going to use factor by grouping. So we factor by grouping, we factor in pairs. Then we factor again. Factor again. Okay, so these are the three ways that we're going to factor out different polynomials after we've taken out the greatest common factor. So make yourself a little chart so you have this handy. It seems kind of basic, but it does make factoring a whole lot easier. So let's go through. We've got some special rules that we haven't seen before and some harder factoring that we want to get good practice at in this section. So let's look at our first example. Our first example has 3 terms. It's a trinomial. It says x cubed plus 2x squared minus 15x, and the directions say factor. Notice it does not say solve. This is not an equation. So even though this says solve polynomial equations, this is not an equation yet. It's just an expression. So I'm only going to factor. So looking at my chart over here, the first thing you always want to do is check your 3 terms, check them all for something in common. I don't have any coefficients in common because 2 and 15 don't have anything in common. But we do have x's in all of these. So we want to factor out the x. That's going to be our greatest common factor, x. That leaves me with x squared. When you factor, you're actually using division. So factor is a form of division. So you're subtracting the exponents. So if I take out an x, I subtract 1 from the 3 and get 2. Then I have 2x to the first power minus 15. So we factored it once with our greatest common factor here. Now we look at what's left, and we're going to factor again. Is it a binomial, trinomial, or factor by grouping? This is a trinomial. So it's going to factor like this. And I should have written that over here. So where can I squeeze that in? This is going to be, that's so ugly, but there you go. So I keep the x, don't drop what you factor. Now I'm considering the factors of 15, knowing that I have different signs here. The negative means different signs. So negative 15 means I'm going to have different signs in the factored binomials. So factors of 15, let's see. If I make a list, even though I could probably figure this one out, I'm going to say 1 and 15, 3 and 5, that's it. 3 and 5, subtract and make the 2. So I need to put 5 and 3. In order to have positive 2, I need positive 5 and negative 3. Check and make sure it works. X times x is x squared. Minus 3x plus 5 is 2. Minus 15 from 5 times negative 3. So now this is factored form. This has 3 factors, and this is an x cubed, and that makes sense. These are the smallest units. I can't get any smaller than x to the first power. These are the smallest units that would, if they were multiplied out, they would give me this original problem. So example 1 had a greatest common factor, and then we factored from there. Let's take a look at a second example. Example 2 says 2y to the 5th power minus 18y cubed. So this is a binomial. However, I never want you to start with the binomial. I always want you to start here at greatest common factor. So looking at this, 2 and 18 have something in common. They have a 2. We can take a 2 out. Y to the 5th and y to the 3rd power have y's in common. The most you can take out is the smallest exponent, so that'll be cubed. What's left is divide out the 2, so I have 1 here. I'm just going to leave it. Divide y to the 5th by y cubed. I have 2 left over. Keep the same sign here. 2 goes into 18 and leaves 9. Y cubed goes into y cubed and leaves 1, and we're done with that part. So check it. 2 y to the 3rd, y squared makes 5th. 2 times negative 9 is 18, y cubed, 2y cubed, that works, okay? Now look at your stuff again. In the last example, we had x to the 1st power. I don't have that here. This one doesn't factor any further, but this does factor, and difference of squares will happen a lot. So this step was taking out the greatest common factor. The next step is going to be to say that 2y cubed stays the same. If you want to look at it as separate powers like this, you could actually say that this is 2 times y times y times y. If you wanted to see it as the first degree, that's perfectly fine. And then now I have a binomial. So I go over here to my list, and the binomials are all something special. So difference of squares is the first one that I have. Y squared minus 9. This is a square, so is this. There's a difference there. It factors as a conjugate, y plus 3 and y minus 3. And now we have the lowest degree. They're all 1 degree. I have 5 of them, 1, 2, 3, 4, 5. And I had a y to the 5th. The 2 is the stretch factor, so that's just a number. You don't count that as a separate solution that we're going to have eventually. All right, so difference of squares in this problem was a special factoring rule as a binomial. We've got 2 more to learn today, and there are sum of cubes and difference of cubes. They are very similar to each other, and there's something you need to memorize. Although something like this can be factored and you can try something, and if it doesn't work, you can try something else. The difference in sum of cubes will be difficult for you to guess and check. So this next thing you're going to need to memorize. So we're going to write that first. Memorize, exclamation point, sum and difference of cubes. So looking at cubes, this is going to be to the third power. This is squares, it's to the second power. So let's do sum first. So this is a rule you need to memorize. Rule. That rule word looks really weird. You know, sometimes I do that. There we go. Rule. Okay, so this rule is going to look like difference of squares. It's going to have a cube and then another cube, and it's either going to have a plus or a minus. So sum and difference of cubes is not just the difference, it's both. So the sum of cubes looks like this, a cubed plus b cubed. The difference of cubes looks like a cubed minus b cubed. It's as simple as that. The factoring, though, is what we need to memorize with our rule. So to factor a cubed plus b cubed, we need to find out what the base is that's cubed. And for this first example, it's just simply a and b. So this is a to the third power and b to the third power. Those bases will be important. To factor it, we're going to use the SOAP rule. Okay, so SOAP is a acronym, is that the right word? That helps us remember that we're going to have these signs. Same sign, opposite sign, that says oop, opposite sign, and then always positive. SOAP. SOAP, SOAP, SOAP. What does that mean? When we factor sum or difference of cubes, we're going to put a binomial and a trinomial. So we have a binomial and a trinomial. And the first thing we're going to put in are the signs, so the pluses and the minuses. If you look at this one, this is a sum. It's got a plus here. So in the binomial, it's going to have a plus. That's the same sign. Plus, plus, same sign. The next sign is the opposite sign. So if this one's a plus, this one's a minus. The last sign is always positive. And by binomial and trinomial, what I'm going to tell you is we're going to put something here and here, and then here, here, and here. So it's going to have 2 terms and then 3 terms. SOAP, same, opposite, always positive. Now the numbers that go in here come from here. So the a cubed, I'm going to put an a in the first position. It's the base of the a cubed. So this is going to be base of a cubed. This is going to be the base of b cubed. No surprise there. Base of b cubed. B. Now, in order to get a cubed, I need to say a times a squared. So it's the first one squared. First term squared. The last one is the last term squared. So b squared is b squared. In the middle is them multiplied together. The terms multiplied. So that's going to be AB. I'm not worried about the signs. It's not A times B is positive AB. I've already done the signs. The signs are taken care of. Okay? So here's your equation. If you have a sum of cubes, you have a binomial and a trinomial. It's the base, A, the base, B, and then A squared, B squared, and multiply these together for the middle term. Let's try that with some actual numbers. So let's say that we have, looking for a pen that's dark. I don't know if this is a different color or not. I think it's still purple. It is. Here we go. All right, let's say we have x cubed plus 8. This is a sum of cubes. X is cubed, 8 is 2 cubed. So you need to find out what the base is. So I found the base. I found the other base. This is a sum. I'm going to factor it into a binomial and a trinomial. Little parentheses, big parentheses. The signs come from SOAP. Same sign. The next sign is opposite. The last sign is always positive. So your signs are easy to plug in. Same, opposite, always positive. And now you take the bases, x and 2. It looks just like this, except no cubes. In here goes x squared. In the last one goes 2 times 2 or 4. In the middle goes 2 times x or 2x. It's a formula you need to memorize. It works exactly the same way for a difference of cubes. So let's try a different one. Let's try 27 x cubed minus y cubed. This is definitely a cube minus another cube. This is 3 cubed, x cubed minus y cubed, all cubed in a difference of cubes. Small parenthesis, large parenthesis. The signs are same. Negative goes negative. Opposite. Always positive. What do I plug in though? I don't put a 27 here. 27 times 27 squared is a really gigantic number if I go to check it. So what do I need to do first? I need to change this into 3x cubed minus y cubed. Now I can plug in from the bases. I take the base, 3x, and the base, which is y. There you go. The first term is 3x squared, so 9x squared. Now check that. Does that make sense? 3 times 9 is 27. X times x squared is x cubed. Y squared goes in the last position. Y times y squared is y cubed. In the middle, I multiply these together. 3x times y is 3xy. I squeeze that in there. Difference in sum of cubes. We're going to take a second and multiply one out and make sure we understand that it actually works. The reason we need the opposite sign here is that things need to subtract. Remember how difference of squares, the middle terms cancel out? Well, the same thing happens with difference or sum of cubes. And so we need that minus sign for that to work. Let's check x plus 2 times x squared minus 2x plus 4. So let's see if that actually works. Whoops, too far. So we're going to check to see if x plus 2 times x squared minus 2x plus 4 actually makes x cubed plus 8. So we're going to multiply it out. X times x squared is x cubed. X times negative 2x, negative 2x squared. X times 4, 4x. Now we're going to do 2. 2 times x squared is 2x squared. 2 times negative 2 is negative 4x. 2 times 4 is 8. X cubed, when I add down, these cancel. These cancel. Plus 8. So yes, it works. So, difference in sum of cubes. Watch this part again. If you need help remembering how to do that, you need to find the bases that are cubed. So you need to find the bases first. Then you need to remember SOAP, same, opposite, always positive, and that you have a binomial and a trinomial. So this is binomial and trinomial. difference in sum of cubes. That's how they work. And they have the same rule. The SOAP helps you with the signs. Okay, so now you have the tools that you need to set up for solving equations. Let's use them and actually solve. So far, we've just been factoring. So let's do a couple things where we actually solve. Let's say that we have, so example 4 is already written out, x cubed minus 3x squared minus 16x plus 48. So we're going to set this equal to 0 and solve. And we're going to use factor by grouping. So we haven't done an example like that. We're going to throw that in this one as well. So factor by grouping says, okay, look at what you have and see if you have a greatest common factor. This one only has x's. This one doesn't have any x's, so I can't use greatest common factor. So next I go to the second group here, and I look at it and say, well, it's not a binomial or trinomial, it's a factor by grouping. It's got 4 terms. So to do that, we're going to factor in pairs and then factor again. So what I want to do is, I have no idea where this crosses the x-axis. I don't know what numbers I can stick in here that would make it 0. So what I'm going to do is factor it and get smaller units that I can solve. And to do that, I'm going to do pairs. So I've got this pair, and then I've got this pair here. And there are things that I can factor out of those. So I'm going to do them one at a time. And I do like to underline when I'm new at factoring by grouping, just so I can do it really well. These two have in common x squared. That's the most I can take out. If I take out x squared out of the first term, it leaves me x. If I take out x squared out of the second term, it leaves me minus 3. So I factored the first pair. The second pair, there's a trick. If there's a minus here, I need to take out the minus. So take out the subtraction sign with whatever you're going to take out. It turns out that 16 goes into 48 3 times. So I'm going to take out negative 16, and I can't take out an x. So that's it, negative 16. If I take out negative 16, the first one will leave an x. If I take negative 16 out of 48, I need to also take out a negative, because negative times negative will be positive 48. And I already said that was 3. Okay, so that's the first factor in pairs. Now I'm going to factor again, and this one might look a little funny, but if you look closely at it, now I have 2 terms, and this first term has an x minus 3, and the second term also has an x minus 3. So what they have in common is x minus 3. So I'm going to take x minus 3 out. And when I take it out, just for fun, I'm going to put a different kind of bracket there because I'm taking out something bigger than x squared. If I take it out of this term, I'm left with x squared. If I take it out of this term, I'm left with negative 16. Note there's only 2 terms here. So what I'm left after I factor is 2 terms equals 0. Factoring means that I need to find the smallest unit. So I don't have this yet at the smallest unit because it's a square. Can I make a smaller unit? And this is a difference of squares. So yes, now I can say x minus 3, I keep it. I can factor this one again. The brackets are not important. I just like brackets when I'm doing factor by grouping. So when I factor this underneath, I'm going to say x minus 4 and x plus 4. Order doesn't matter. Now I have 3 terms. This was a cube and I have 3 terms. We have found the smallest units that make up the original problem, set them equal to 0. The whole goal is once you have the smallest units, you can say, well, hey, if this one was 0, the whole thing would be 0. If this one was 0, the whole thing would be 0. Or if this last one is 0, the whole thing would be 0. That's the zero product rule that lets you make 3 tiny equations that are easy to solve. You can actually solve them. You could solve them from here if you understand opposite math. When I solve this first one, I'm going to add 3 to both sides and get x equals 3. When I solve the second one, I'm going to add 4 to both sides and get x equals 4. And the last one, if I subtract 4 on both sides, I get x equals -4. But notice how each of these factors has opposite math. We've talked about that before, but I just want to emphasize that point. You don't have to write it like this. You can totally just say x equals 3, 4, and -4. It doesn't matter to me if you write them in smallest to greatest order. It's just a list. So these are the solutions. If we plug them in, we're going to get 0. If we plug in 3 everywhere, we're going to get 0. If we plug in 4 into all the x's, we'll get 0. They're solutions, and that means on a graph, these are x-intercepts. Because the y value is 0. This is the y value, and we've made it 0. Okay? So we put a big box around those. We're so happy. We now have those solutions. So in your factoring, check first to see whether it's something you're factoring just to get a factoring out, or whether you've set it equal to something and you're solving. You can only solve if you have an equation. If there's no equation, please do not assume that it's equal to 0. Don't assume anything, just stop, just factor, and don't actually go so far as to solve it. Remember the difference in sum of cubes, you will have some of those. Also remember, if you got to something complicated that didn't factor again, like this difference of squares, let's say for just a second that we got to this place. Let's say, for example, 4a, that it was a different problem from the beginning, and we got it here. X minus 3 times x squared plus 16 equals 0. If we got to this stage, then we would be able to solve it because we have small equations, but some of you are going to want to factor this, and it doesn't factor. In squares, we only have difference of squares. This is not a difference. So this is the smallest units that this factors into. However, we can make two equations. X minus 3 equals 0, and x squared plus 16 equals 0. We set each factor equal to 0. This one is easy to solve. X equals 3. This one's a little bit harder. You're going to want to say 4, and it's not 4. 4 doesn't work. You might even say -4, but it doesn't work. You need to go ahead and solve the equation correctly. You need to take 16 and subtract it from both sides, so x squared equals -16. You need to take the square root, and when you write the square root on both sides, you need to write plus or minus. You need to not forget the plus or minus. It's very important. Also, when you take the square root of a negative number, you're saying that the negative is the -1. This is equivalent to the square root of -1 times the square root of 4 times the square root of 4. 4 times 4 makes 16. -1 gives you the negative. And this makes a pair that's 4 on the outside. And the -1 square root makes it I, and the plus or minus. What will help you to remember the plus or minus is that this original equation is x to the third power. X times x squared is x cubed. You need 3 solutions, 1, 2, 3. So sometimes you won't be able to factor down to the first degree. You'll have to stop, but you can set an equation equal to that and solve it from there. That's the only way you're going to get imaginary answers. All right, so there you go. Go ahead, start memorizing SOAP and the sum and difference of cubes, and factor away to your heart's content. Please do check your answers to make sure you factored correctly. All right, see you next time.